Introduction to Statistics, Chapter 2, Section 2.2, Organizing Quantitative Data. Frequency distribution for discrete data. A frequency distribution lists each category of data and the number of occurrences for each category of data. Steps to create a frequency distribution for a set of discrete data. Draw a table consisting of 2 columns and enough rows to include each category and a column label. Label column 1 as category and column 2 as frequency. List all different possible values into category column. Go through the data list and count the number of each value present and enter this number in the frequency column of the table. Let's look at an example. If I gave you this set of data and I wanted you to create a frequency distribution, first, count the number of different categories, numbers in this case. There would be 5. 1, 2, 3, 4, 5. Draw a table, 2 columns, 6 rows. Label columns, number, frequency. List categories, 1, 2, 3, 4, 5. Now, count how many in each category. So I'd go up to my data set, count how many ones. So if I count the ones, I turn out there's 8. Then I'd count the 2s, the 3s, the 4s, the 5s, and I'd find 5 2s, 4 3s, 5 4s, 2 5s. And this would be my frequency distribution. Now, relative frequency distribution. A relative frequency is the proportion or percent of observations within a category and is found using the following formula. Relative frequency equals frequency divided by sum of all frequencies. A relative frequency distribution lists each category of data together with the relative frequency. Steps to create a relative frequency distribution for a set of qualitative or discrete data. Create a frequency distribution table. Draw a table consisting of 2 columns and enough rows to include each category and a column label. Label column 1 as category, column 2 as relative frequency. List all different possible values into category column. Find the relative frequency for each category and enter this number in the relative frequency column of the table. So if we look back at the example we just did, we made a frequency distribution. Now what we're going to do is take that frequency distribution to create our relative frequency distribution. First, find the sum of all frequencies. In this case, there are 24. So then I would take each frequency and divide it by 24 to get the relative frequency. So 8 divided by 24, rounded off to 3 decimal places, would be 0.333. 5 divided by 24 is 0.208. 4 divided by 24, 0.167. 5 divided by 24, 0.208. And 2 divided by 24, 0.083. Now I have a relative frequency distribution. Histogram for discrete data. A histogram is constructed by drawing rectangles for each class of data. The height of each rectangle is the frequency or relative frequency of the class. The width of each rectangle is the same and the rectangles touch each other. Creating a frequency histogram. Let's use the frequency distribution from our previous example. So I would draw a graph with the categories along the horizontal axis and the frequencies up the vertical axis. Now I would draw a rectangle for frequency of 1, category 1, which is 8. So I draw a rectangle up to the 8. Now I go to category 2, 5. So I draw another rectangle up to 5, but make sure the rectangles touch. This is the difference between a histogram and a bar graph. In a bar graph, the bars are separated. In a histogram, the bars touch each other. And then category 3 would go to 4, category 4 would go to 5, category 5 would go to 2. And this would be our frequency histogram for this frequency distribution. Now, relative frequency histograms. Again, same idea. We take the relative frequency distribution, we draw a graph with the categories along the horizontal axis, but this time we put the relative frequency up the vertical axis. So I used 0.1, 0.2, 0.3, 0.4 as my categories. Now, category 1 goes to 0.333, which is a little above 0.3. And then category 2 is 0.28, a little above 0.2. And in category 3, category 4, category 5. So we just draw the rectangular bars to the proper height and then make sure they touch. Now, whenever you have a large set of discrete data or continuous data, we use classes to group the data. Classes are categories into which data are grouped. A lower class limit is the value, the smallest value allowed in a class. An upper class limit is the value of the largest value allowed in a class. The class width is the difference between any two consecutive lower class limits or any two consecutive upper class limits. Now, here's a table. Let's look at this example. Question number 1. When you're given a frequency distribution, you should be able to answer some questions. Question 1. How many classes exist for this set of data? If you look over here, count the classes, there would be 5 different classes. Now, what are the classes? Well, the classes are the ranges. 25 to 34, 35 to 44, 45 to 54, 55 to 64, 65 to 74. What is the class width for this set of data? Well, the class width would be 10. If you take any two lower class limits and find their difference, you would find 10. For example, 35 minus 25 is 10. 55 minus 45 is 10. Or take any two upper limits. 54 minus 44 is 10. 74 minus 64 is 10. The difference between any two lower consecutive limits or any two upper consecutive limits. What are the lower class limits for this set of data? Well, the lower class limits would be 25, 35, 45, 55, 65. The upper class limits, 34, 44, 54, 64, 74. Now you notice the upper class limit is one less than the lower class limit of the next class. How many individuals are in this set of data? You would add up the frequencies, find that there are 70. Which class contains the max number of individuals? This would be class 1, which is 25 to 34, because there's 23 in that class. Now, what percent of the individuals are in the fourth class? Now, percent is like relative frequency. It's relative frequency represented as a percent. So we have to find the relative frequency for the fourth class. Well, the fourth class has 7. There's a total of 70. So we take 7 divided by 70, we get 0.1 for the relative frequency. But now, change this to a percent. 0.1 is 10%. So 10% of the individuals are in the fourth class. Using the frequency distribution below, complete the relative frequency distribution. In the quiz, you will be given some frequency distributions and asked to find relative frequency distribution. This is going to have to be done using a calculator, by hand using a calculator. So in this case, we add up the frequencies, there are 70. So I take 23 divided by 70, 0.329. Then I take 15 divided by 70, 0.214, etc. Now I just keep dividing down through until I fill in the relative frequencies. And be careful. Make sure you look and see how many decimal places they want it rounded to. In this case, I rounded to 3 decimal places. One other thing you should be aware of. The sum of the relative frequencies should equal 1. Sometimes rounding will throw you off a little bit, but in reality, the sum of the relative frequencies should equal 1. Determining classes. How do you determine classes if you're just given a large set of data? Well, we choose the smallest observation in a data set or a convenient number slightly lower than the smallest observation to be the lower class limit of the first class. Then we determine the desired number of classes. This is usually somewhere from 5 to 20. Third, determine the class width using the following formula. Class width is the largest data value minus the smallest data value divided by the desired number of classes. But the thing to remember, you always round this answer up. Step 4, build the table starting with the lowest class limit. Okay, let's look at an example. If I gave you this set of data and I wanted you to create a table consisting of 6 classes, first thing I'd have to do is go through the data set and find the smallest data value, which is 2.0. Then I have to find the largest data value, which is 18.9. Now I'd have to calculate the class width, which is 18.9 minus 2.0 divided by 6, which is 2.81666, and that would round up to 3. So now I create my table. I start with the first lower class limit to be my smallest data value, 2.0. Now I add my class width to it, so 2.0 plus 3 is 5.0. Add the class width again, 8.0. Add class width, 11, 14, 17. They would be the lower class limits. Now the upper class limit is one less than the lower class limit of the next class. So in this case, the first class would end at 4.9. Since everything was in one decimal place in our data set, we're going to use one decimal place. So then the second class would be 7.9, 10.9, 13, 16.9. Oh, now how do we get the last upper class limit? Well, now we go back to what we said. Class width is the difference between any two upper class limits, right? So we can just take the 16.9, add the class width, which was 3, and you get 19.9 for the upper class limit of the last class. Now we have developed the classes. Then you would go through the data, count how many is in each class. We're going to leave that for later. Okay, StatCrunch will not create a frequency table for group data, but you may use StatCrunch to draw a frequency histogram and gain your desired information from the histogram for your table, which we'll talk about here shortly. Same thing with relative frequency. StatCrunch won't give you a relative frequency table for group data. It won't put it into groups, but you can do a relative frequency histogram and gain your desired information. Now, creating a frequency histogram for continuous data. If you have a frequency distribution, first label the lower class limits of each class on the horizontal axis, add an additional lower class limit by adding the class width to the last lower class limit, label the vertical axis with frequency, then draw rectangles to represent the frequency of each class. So if we take our frequency distribution below, dealing with age, I would draw a graph with my lower class limits along the horizontal, and then I put frequency on the vertical axis. Now I'm going to draw a bar starting at 25 going to 35, 6 high. This would represent the first class. This is from 25 to 34, even though it goes from 25 to 35 on the graph. The next bar would go to 5. That's the second class, 35 to 44. Third class, 45 to 54, etc. And now we have our histogram. So if you have a frequency distribution, this is what the histogram would look like. Now, if you have a set of raw data, that is, you have all the individual members listed like we did earlier. Option 1, by hand, you could create a frequency distribution and follow the steps outlined in the previous slide. Or option 2, you could use StatCrunch. First, you would load the data into StatCrunch, select a graph on top menu, and then histogram. Click on the variable column you wish to summarize. Choose type of histogram, frequency. Under bins, enter lower class limit of first class for start at. Enter class width for width. Click compute. Okay. If data is already in the frequency distribution, StatCrunch may not be used to draw a histogram. Let me stop this for a second and go look at an example. Okay, in StatCrunch, here's a list of data. If I look at this list of data, the smallest data value is 5. The largest data value is 42. So if I would take 42 minus 5, and let's say I want 6 classes, divided by 6, that's going to be 6 point something, and so I'm going to round that off to 7. So what I'm going to do is I cannot make a frequency distribution table, but I can do the histogram. So I go under graph, I go to histogram. Now I click the column that contains my data, which is variable 1. I go down to bins. Under bins, I also pick type. I could pick frequency, relative frequency, or density. I want frequency this time. Start at, well, my lowest value was 5. I said I wanted to use a class width of 7. Another nice feature about histograms, if you're going to try to make a frequency table, is right down here, it asks you for display options. Value above the bar. You could click value above the bar, and now you click compute. Here is your histogram. Your values of each bar are listed above, and your lower class limits are down on the table. So knowing your lower class limits, you could create a table. And the frequencies are here. But this would be the frequency histogram for that set of data. All right, now going back to the PowerPoint. Creating a relative frequency histogram for continuous data. If you have a relative frequency distribution, first label the lower class limits of each class on the horizontal axis, add an additional lower class limit by adding the class width to the last lower class limit, label the vertical axis with relative frequency, then draw your rectangle. Very similar to what we just did for frequency. So here was our relative frequency distribution. So if I draw the graph, I still put the classes of lower class limits along the horizontal, but this time my vertical scale is relative frequency. So I'm going to use 0, 0.08, 0.16, 0.24, 0.32. So I just label it, and I chose to go by 0.8s. So then I draw my bars to the proper places, make sure the bars touch each other. And this would be the relative frequency histogram for this relative frequency table. And you should be able to compare the graph with the table to know that it is correct when you take your quizzes. Now, what if you have a set of raw data? Well, option 1 by hand. Create a relative frequency distribution and follow the steps outlined in the previous slide. You can do it by hand. We could also use StatCrunch. You notice these directions are going to be exactly the same as what we just did for a frequency, except for now we're going to choose relative frequency. And once again, if the data is already in a frequency or relative frequency, StatCrunch is no good. Let me stop this, go back to our previous table. This time, I want to do a relative frequency histogram. I would hit graph, histogram, click my column. This time under type, I would choose relative frequency. My bins, we had them starting at 5. We had a width of 7. If you recall, and I'm going to value above the bar, I'm going to represent the value above the bar. So I click compute, and now you notice we still have the lower class limits along the horizontal axis, but now we have relative frequency up the left, and the bars are touching each other with the relative frequency of each bar at the top, which meant in class from 26 to 33, 0.14 means 14% of the data was in that class. And from 40 to 47, that would be 5% of the data. Okay, so this is how you make a histogram using StatCrunch. Back to the PowerPoint. Stem and leaf plots. A stem and leaf plot is another way to represent quantitative data graphically. Every stem and leaf plot consists of a title, stems, leaves, and a legend. Your author uses the philosophy that the digits to the left of the rightmost digit form the stems, and the rightmost digits form the leaves. So an example, if I took this example, age would be my title, 2, 3, 4, 5 would be my stems, the part in blue would be my leaves, and my legend would be at the bottom. Tells me what 3, 2 represents is 32. Now, the next part you should be, how do you get the raw data from a stem and leaf? Well, if you look at the stem and leaf, what we're going to do is go across the first row. That 2, 3 means 23. The 6 means 26. 7 means 27. Go to row 2. 3, 1 is 31. 3, 1 is 31. 34, 35. Next row would be 40. Bottom row would be 52, 53, 53. And this is how you list the raw data from a stem and leaf plot. Following example will illustrate split stems. Okay, if you had a non-split stem, which is what I just showed you, 2, 3, 4, 5. Now, a split stem, what it does, it takes every stem and splits it into 2. So instead of having just 1 2, we have 2 2s. 2 2, we have 3 3, 4 4, 5 5. We split the stems. Why do we do this? Now, so that means the first 2 stem is going to be leaves 0 through 4. And the second one is going to be leaves 5 through 9. Sometimes this is done so that you don't get extra long lists of data under one stem. In other words, if there's a lot of data in one stem, splitting it sort of shrinks it down a little bit. And this would be the difference between a non-split and a split stem. Now, we could have double-sided plots. Okay, for example, we could have an age plot for males and females. Down the center, the 2, 3, 4, 5 would be the stem. The leaves for females would be on the right, the leaves for males would be on the left. The legend stays the same. Now comes the question. Raw data for males. Well, again, you're reading from the center out, and the values should be put in order. For example, under the male, you see how it's 420. Well, that's counting from the stem 2 going out. So that's going to be 20, 22, 24. And then the next row would be 35. Next row would be 43, 46, 48, 49, etc. until you get down to 54. So that would be the raw data for males. On the female sides, start with the first row. It's going to be 23, 26, 27, 31, 31, 34, 35, so on. So this would be for the females, down to 53. Do they have to have the same number of data? No. You could have a certain number of males, certain number of females. They do not have to be the same. Okay. When given a stem and leaf plot, you should be able to answer questions similar to the following. What is the title of the stem and leaf plot? What is the largest data value in your set of raw data? What is the smallest data value in your set of raw data? Which data value appeared most often in your set of raw data? What is the set of raw data used to create the stem and leaf? This is where you would have to list all the values in the raw data. Now, if you're given a set of raw data, you may use StatCrunch to create a stem and leaf plot. Okay, the steps to using StatCrunch. Load data into StatCrunch, select graph on the top menu, then stem and leaf. Click on the variable column you wish to summarize, click compute. Now, note StatCrunch creates split stem and leaf plots. So let me go end this. Go over here, let's take the same set of data that we've been working with. This time I'm going to do a stem and leaf. So I click graph, come down to stem and leaf, click it, click on the column. Now, outlier trimming, you could, leave that as extreme only, or you could click none. Compute, and here would be your stem and leaf. You notice they only had 1 for the 0, but then they had 2 1s, 2 2s, 3 3s, and 1 4. So they did a modified split. They only showed 1 0 when in reality they should have shown 2. They only showed 1 4 when they should have shown 2. Okay, back to the PowerPoint. Now, dot plots. A dot plot is another way to represent quantitative data graphically. Every dot plot consists of a title, categories labeled on the horizontal axis, and dots above the categories to represent an occurrence of that category in the data set. The frequency of a category is determined by the number of dots above the category. Okay, if I look at this example, we're talking about boxes of candy sold by students. Okay, along the horizontal axis I put boxes. So I have 23, 24, 25, all the way up to 33. Then I put dots above each one. What do those dots mean? Well, at 23, that means 2 students sold 23 boxes. Above the 24, 1, 2, 3, 4 students sold 24. Above the 25, 1 student sold 25. So, how many students sold 30 boxes of candy? In this case, it would be 2. Okay, next, shape of a distribution. A distribution may be described by one of the following. There are 4 ways to describe the shape of a distribution. First, we could have a uniform distribution. This is a distribution in which each category has the same frequency. Now, an illustration of this would be if I had the following. From 25 to 35, let's say I had 5. 35 to 45 was 5. 45 to 50 was 5. Every category has exactly the same frequency. This would be a uniform distribution. Second, a bell-shaped, symmetric, or normal distribution is a distribution in which the highest frequency occurs in the middle and the frequencies tail off to the left and to the right of the middle. So an illustration, I would start in the middle with my highest. Now you notice the one on the left, the one on the right, are they exactly the same height? No, we'd like to get them close to the same height. They don't have to be. And then we tail off and we have this. So you notice the highest point is in the middle, it tails off to the left, tails off to the right. This is not a perfect bell-shaped curve or perfect normal, but it is bell-shaped. Okay, number 3, a skewed left distribution is a distribution in which the tail to the left of the highest frequency is longer than the tail to the right of the highest frequency. So, illustration. If I had this, if these were my bars, if you look closely at the bars, the highest bar is between 65 and 75. And if you look to the left tail is longer than the right tail. So this is called skewed left. Now number 4, skewed right distribution is a distribution in which the tail to the right of the highest frequency is longer than the tail to the left of the highest frequency. So again, an illustration. If I went and drew my bars, if this was my distribution, okay, I would notice the right tail is longer than the left tail. So this would be skewed right. So those are the 4 different categories for a distribution. You could have uniform, bell-shaped, skewed left, skewed right. And this brings us to the end of section 2.2.